Welcome back. This is an Aleks homework video on predicting the reactants of a neutralization reaction. Okay, it seems pretty mean, but they're going to give you the products and ask you to find out what the reactants were. So it's almost like a backwards thinking. What would the reactants have to be if the products of a neutralization reaction are whatever they give you? So I have to remember that a neutralization reaction, okay, neutralization is simply going to be some kind of an acid and a base reacting together in order to neutralize. And often it's going to be a strong acid and a strong base if they neutralize completely to form water and a salt. Okay, so if you have any kind of weak acid or weak base that's reacting together, you might not have full it won't go to full products. You'll end up with some leftover reactants, but often in a strong acid, strong base situation, you'll have completely products of a salt and water. The other thing that I have to keep in mind is that the water comes from the proton of the acid, the H that the acid gives, and the hydroxide that a strong base would have. All right, so HOH. So that's the first thing I did, is I rewrote this as whatever salt, this happens to be barium nitrite, and water, and I just rewrote water as HOH rather than H2O, because I know that they're going to break apart into ions, at least in the reactants they will. So that's what I did. I broke them apart into ions. Now, the periodic table tells me that barium is in the second group. That means it has a positive 2 charge. It's a cation with a positive 2 charge. The NO2 that joins with it completely balances that, so there's 2 NO2s, and it balances with a positive 2. That means each of them had to be -1. So I have 2 NO2 -1s. So I'm just breaking them into ions. Then I broke the water into ions as well. I broke the water into 2 protons and 2 hydroxide ions. When you have a chemical reaction, the same little, think of these as Legos that make a toy, little pieces that make up something bigger. Well, these are going to be the very same things at the beginning of a reaction and at the end. They're going to reconfigure in different ways, but what they're made up of are the same. So these little guys at the end of the reactants will be the same as the products. So I just basically doubled it. I put the very same anions and cations at the beginning as I did at the end. The reactants will have the same materials as the end, so I simply doubled it. I broke it into anions and then doubled it. And now I'm going to switch partners. So we see in the products here, barium is joining with the nitrite ion, so BaNO2 subscript 2. Well, in the reactants, it's going to be with the different anion. It's going to be with the other possibility, because you see here, I've got 2 positives, I have 2 cations, and I have 2 anions on both sides. So whatever they're joined with at the end, they're going to be joined with the other one at the beginning. So instead of joining the barium with the nitrate like that is in the products, I'm going to join the barium with the hydroxide. And I'm going to see that the 2 hydroxide ions will join with the 2 positive charges of the barium, and that will be barium hydroxide. And then that leaves me the proton to react with the nitrite ion to make nitrous acid. So those are the 2 things that will come together. So I just rewriting them. So I put the barium with the hydroxide. I have barium hydroxide, BaOH subscript 2, and that's balanced. Now make sure you put the states here, aqueous. Any of the acids, bases are aqueous. Salts are aqueous. The water will be liquid. Okay, you have to include that. Then the other one was the nitric acid, or the nitrous acid, HNO2, and there's 2 of those. You can see I have 2 of the anions and 2 of the cations there, so there's 2 of those. And then I simply recopied what they gave me at the beginning, the barium nitrite and the water. And that's how you do it. It's not easy, but it is predictable. You're essentially looking for the other partner. Whatever that the cation was attached to in the products, it will be attached to the other species in the reactants. And you also know that the water is going to break apart into a positive hydrogen cation and a hydroxide anion. So I hope this helps.